Hi guys, so in my presentation I'll be going over the topic of batteries. And to start off, I'll be giving an overview of the history of batteries. So in the 1740s, an Italian scientist by the name of Luigi Galvani discovered electricity in frog legs. He was pretty much dissecting a frog attached to a brass hook with an iron scalpel, and the leg ended up twitching, so he thought the frog had electricity in it. But in the 1800s, another scientist by the name of Alessandro Volta disagreed with this statement and said it was actually the metals that were creating electricity rather than the frog itself. And Volta created the first true battery, which consisted of layers of copper and zinc divided by layers of paper covered in brine, and this was known to be the voltaic pile. And the problem that came with his battery was that it couldn't hold electricity for a long time, so electrolytes were leaking, which caused short circuits, and there were hydrogen bubbles on the copper, which increased resistance. But afterwards, in 1820, another scientist by the name of John Frederick Daniel created a new cell battery which solved the hydrogen bubble problem that the voltaic cell was having. And his battery had a voltage of 1 volt. And then afterwards, in the late 1850s, a French scientist by the name of Gaston Blount created the lead acid batteries, which were known to be the first rechargeable batteries. And then in the 1860s, another French scientist by the name of Leclanche created carbon zinc batteries, which were known to be the first dry cell batteries. And then in 1899, we were introduced to nickel cadmium batteries, which were created by a scientist by the name of Waldemar Juckner. And these batteries were becoming less and less used because of how toxic cadmium was, but it did pave the way for the modern usage of batteries. And then in 1955, we are introduced to alkaline batteries, which are the most widely used batteries in the world. And they are popularized by brands like Duracell and Energizer, and they're used in a lot of household devices like remotes and flashlights. And it was created by Canadian engineer Louis Urey in the 1950s. And then afterwards, in 1989, nickel metal hydride batteries were introduced, and these batteries were rechargeable just like the nickel cadmium batteries, but they were less toxic and more environmentally safe. And then in the 1990s, lithium ion batteries are introduced, and they have high energy density and were released by Sony in 1991. And then next, I'll be discussing the types of batteries. So they're in two categories, which are primary batteries, which are non-rechargeable, and secondary batteries, which are rechargeable. Primary batteries usually have a lifespan of 10 years, and they consist of batteries like alkaline batteries, lithium batteries, mercury batteries, and zinc air batteries. And then usually we see secondary batteries in devices like our cell phones, our laptops, etc. And they consist of lead and gel batteries, lithium ion batteries, nickel cadmium batteries, nickel metal hydride batteries. And there are, of course, other types of batteries too, that are industrial batteries used in industrial settings and vehicle and automotive batteries. How do batteries work? So there are three main components: the anode, cathode, and the electrolyte. The anode is the negative part of the battery, the cathode is the positive part of the battery, and the electrolyte is just an acid that's in the middle. So electrons flow from a region of higher concentration to a region of lower concentration. That region of higher concentration is going to be the anode, and the region of lower concentration is the cathode. And then the electrolytes pretty much reacts with the anode and cathode. So electrons are flowing from the anode to the cathode, but the electrolyte stops this from happening. So this is where an external conducting wire comes in, which pretty much allows that flow to start up again. So the anode electrons are going to go all the way to the cathode, and anything that's put in the circuit that is attached to the battery is going to light up or run. And then here's an example problem that pretty much we did in class, and we're just finding the terminal voltage when the current is drawn from the battery at two different currents. You could take a second to pause and solve this, and then the answer will pop up shortly. So pretty much the voltage terminal is found by taking the EMF and subtracting it by current times resistance, and these are the two answers that we get. And then I will be talking about, lastly, the development of batteries and the future of battery technology. So the main challenge that many scientists are trying to tackle currently is how to get longer lasting batteries in a small and lightweight design. For example, like our cellular devices, most phones have really small batteries, but we also want them to last longer. So scientists are mainly working on adjustments and improvements to the already commercialized lithium ion to progress in battery technology. And then Tesla is a pretty good example of working on improvements of batteries, as they've already made significant advances in battery design and production through its Gigafactory, which pretty much three things that led to this advancement was their better engineering and manufacturing processes. Their wider and longer cell design allows more materials packed into each cell, and then their battery cooling system allows more cells to fit into the battery pack. So pretty much with these developments and improvements in manufacturing, even though there are lots of challenges and obstacles in the way, can potentially help us to move into a renewable energy setting and the use of electric cars more. And then these are basically the sources that I've used to research, and that concludes my end of my presentation.